I'm Kaustuba. I'm doing my ADA assignment where I have to make a video and upload it on YouTube. My topic given was Floyd's algorithm. I have to explain the program Floyd's algorithm. My USN is 1BI23CS109. So the program purpose for Floyd algorithm is to compute the shortest distance between every pair of vertices in a weighted graph using Floyd's algorithm, which is based on dynamic programming. I will be explaining line by line of the code, so it will be very easy to be understanding. So first we are going to include a header where it includes the standard input output library to use printf scanf. Next we are going to define inf where it defines a symbolic constant inf as 999 to represent infinite distance, no direct edges between the nodes. Next, the small snippet, code snippet would be where a utility function to return the smaller part of two values. When there are two values, it returns a smaller value, so we can compute the shortest distance between the two nodes. And the next one would be where we include int ijk to use it for the loops. We are declaring ijk to use it in the loops. The outer loop k represents the intermediate vertex where we are checking if using k as an intermediate gives a shortest path from I to j. Next, for the I loop, it is source node would be I, and for the j loop, the destination node will be j. Here, in p of ij is equal to minimum of p of ij comma p of ik plus p of kj, where the core step would be to update the shortest path from I to j. If path I is pointing towards k, then k is pointing towards j. It is shorter than direct I is pointing towards j, where it updates it. This step happens for all possible I comma j pairs with each k as an intermediate, hence all pair shortest path. Next, we open to the void main where we declare int a of 10, where we declare array of the size 10, and then I comma j where we're declaring other variables too for loops. Then we are entering the number of vertices, where we take input, where we take the input from the user. Here we enter the adjacency matrix. A of ij should be the weight of edge ij. If no edge, user should enter 999 inf. Next, Floyd of an, where we call the Floyd's algorithm function to compute all the shortest paths. Print of shortest path matrix would be where the output label appears. Then the small code snippet where it prints the final shortest path matrix. A of ij is the shortest distance from I to j. Now when we come to the main thing where how it solves the problem, it uses dynamic programming where initially a of ij contains the direct edge weight. It tries to improve a of ij by checking if it's going through k is shorter of a of ij, where it uses this where a of ik plus a of kj is lesser than a of ij. It repeats this from all the vertices as intermediates. After all iterations, the matrix contains the shortest path between all the pairs. Time complexity of this program would be O of n cube, where 3 nested loops over n vertices works well for small to medium graphs where n is lesser than or equal to 100. For large graphs, more efficient algorithms like Johnson's are used. Floyd's algorithm finds the shortest path between every pairs of the nodes, where it updates paths by checking if going through an intermediate node gives a shortest path. It uses dynamic programming, storing and updating sub-solutions. The final matrix tells you the minimum distance between all the node pairs, and the time complexity of it will be O of n cube, so it's good for dense and smaller graphs. If it's above 100, if the input of n would be above 100, then we have to use more efficient algorithms such as Johnson's algorithm. Now, before we give an input where we take out the output, we should first have a graph where we will first construct a matrix. So here we are using this graph where we are using this graph where we find the shortest nodes between the shortest path between these nodes. So when we update the matrix, we do it like this. We find the shortest path between a to a, whereas a to a doesn't has any path, so it updates itself as 0. And from A to B, as we can see, we don't have any other paths, so we update it as infinity. So from A to C it's 3, and from A to D it's not directly connected, so we need a shortest path, so we keep it as infinity. Then from B to A, it's we take it as 2, and remaining values should be updated the same way. This will be the final matrix after you update all the values. So we should be careful while updating the values, when to put 0 and when to put infinity. Zeros would come diagonally because there is no loops where or the paths where it takes to leads to themselves. Like A to A there is no path, and B to B there is no path, C to C there is no path, and D to D there is no path. There is no direct path leading to themselves. Now we put the values in our output, where we put the n as 4, as it's a 4 into 4 matrix, and we have 4 nodes. So we put the let's jump into the program and put the value. Now we run the program, enter the number of vertices, it's 4. Now we put the values where it's 0, and it's mentioned over here itself, use 999 for no direct edges. So wherever there is infinity in your matrix, you must put 999. 3. All the values are updated. So the shortest path matrix for all the pairs would result as this. This was the assignment that was allotted to me. Thank you.